Hi, so in this video, we're going to be proving that a paragram is a rhombus or a rectangle or a square. For this, we're going to be using three particular theorems that comes directly from the properties of rhombus or the properties of rectangles or the properties of the square, right? The first one is theorem 616 that says if the diagonals of parallels are perpendicular, so the diagonals are perpendicular, then the parallelogram is a rhombus. Right? So if AC is perpendicular to BD, that means that ABCD is a rhombus. Right? Now, 617 says that if one diagonal of a paragon bisects a pair of opposite angles, one diagonal, so we don't need now both diagonals. With one, we can prove it. Then the paragon is a rhombus. So that means that DB bisects angle B and angle D. So that means that ABCD is a rhombus. The last one we're going to be using says that if the diagonals of parallels are congruent, then the parallelogram is a rectangle. So right here I have that parallelogram. I have that AC is congruent to BD, so that means that ABCD is a rectangle. So let's use this information or those theorems in a couple of exercises. My first one says, can you conclude that the parallelogram is a rhombus, rectangle, or a square? Explain. And again, remember that we're using the best description, right? So in this case, I have one diagonal that is bisecting two pairs of angles. So that diagonal is bisecting angle C and angle E. So that means that because of that is a rhombus. It's a rhombus. Okay, so the next one. I have that the diagonals are congruent. How do I know that the diagonals are congruent? Because it's stating that this place of this diagonal is congruent to all pieces, right? Every single piece of the diagonal, right? So if RP bisects OQ, right, it divides on half. So because all of them are congruent, that means that this is a rectangle, right? Again, because each diagonal divides on half the other diagonal. So if it forms every single piece that is congruent, that means that the diagonals are congruent. So the next one, I have that the diagonals are perpendicular right there. You can see it right there. So because the diagonals are perpendicular, this is a rhombus. Rhombus, right? Because US is perpendicular to RT. Then I will say I want to find the value of X in the figure that given a special parallel. So in this case, I want to find if what it is X if this figure is a rhombus, right? As we know, each pair of diagonals bisect a pair of opposite angles. So that means that each, because this is a bisector, that means that those two angles are congruent. So their measure has to be the same. So 6x equals 32 equals 17x minus 1. So plus 1 plus 1. So 6x plus 33 equals 17x minus 6x. 33 equals 11x. And I'm just dividing, so x has to equal to 3. So in this case, for this to be a rectangle, it must mean that every piece here is congruent. So in this case, 2x plus 6 equals 3x minus 6. So plus 6. 2x plus 12 equals 3x minus 2x means that x equals 12. My next one again is a rectangle, right? So every piece of those diagonals are congruent. Why? Because it is a rectangle. That means that AY is congruent to XZ. Right? You have it right here. So that means that if XZ divide AY in half, and the same the other way around, AY divide XZ in half, So that means that it's cutting every piece in the same distance. Right? So 6x minus 3 equals 5x. So minus 6x. So negative 3 equals negative x. And now I'm just dividing by negative 1. So x equals 3. Okay. Determine whether the paragram is a rhombus, a rectangle, or a square, given the most precise description in each case. It says a paragram has perpendicular diagonals. So I know that it has perpendicular diagonals. And its angle measure 45, 135, 45, and 135. So in this case, because it has perpendicular diagonals, it could be a rhombus or a square. Right? It could be a rhombus or a square. But to be a square, its angle has to be right. So the only possibility here is to be a rhombus. Next, my paragram has congruent diagonals. So again, the rectangle and the square have congruent diagonals. But because I don't have more information, I have to conclude that this is a rectangle. I cannot tell that it's a square. Next, it says a woman is plotting out a garden bed. She measures the diagonals of the bed and finds that one is 22 feet long and the other diagonal is 23 feet long. Could the garden bed be a rectangle? Remember again that the properties of rectangles state that the diagonals are congruent. So in this case, no, it cannot be a rectangle. Why? Because the diagonals are not congruent. The next one. A girl cut out rectangle pieces of cardboard for a project. She checked to see that they are rectangle by determining if the diagonals are perpendicular. Would this tell her whether a piece is a rectangle? Explain. So in this case, it's asking to see. She's just checking to see if the diagonals are perpendicular, right? So in this case, it will not tell her. It will not tell her if the pieces are a rectangle. Why? Because the diagonals of a rectangle are not necessarily a perpendicular. So no, right? She should check if the diagonals are congruent. And that's it for this lesson. May the force be with you.